These are the solutions for the study aid for algebra quiz number 15. So let's take a look at our first problem here. And what it's asking us to do is write each expression in simplified radical form. And so what we're going to end up doing to start with is we're going to go ahead and rewrite this as a radical, remembering that the denominator represents the number of roots. So we have 5 roots of a all raised to the third power. I would take credit for that, or you could write it this way, 5 roots of a cubed. That means the same thing, so either answer would be fine. This next one, though, we want to simplify it. So if there's a perfect cubic root in this expression inside the parentheses, we need to take that out. And so what I've got to start with is this, the cubic root of 54y, and then I'm raising this to the second power. So I'm going to take out the perfect cube in 54. So what I see is that 27 times by 2 makes 54, and then I still have the y, and then I'm raising this to the second power. So you see 27 is a perfect cube, which makes 3, so I have 3 times by the cubic root of 2y left over. Again, I'm still raising this to the second power. So here's where I go ahead and square all the parts. So I'm squaring both the 3 on the outside of the radical sign, the 2 inside, and the y inside. So what I'm left with is 3 squared cubic roots of 2 squared y squared. And so I can go ahead and square the numbers, and so my answer is going to be 9 cubic roots of 4y squared. Well, moving on to the next one, I've got to change this radical expression into an exponential expression. So the first one is just v to the 2/3 power. That would be the answer. So whatever the index is goes in the denominator, the power here goes in the numerator. So I'm looking for 4 numbers that multiply to make 256. Well, I see that 4 times 4 times 4 times 4 makes 256, and so I found that this is going to be 4a to the 8/4 power. Well, I can reduce that 8/4 power by just writing this as 4a to the second power. Again, the 256, the cubic fourth root of that, ends up making 4. And so on this one, they asked me to graph this function. So if you're a little unsure about what it looks like, let's go ahead and set up a table. And so my table has x, my inputs, and then 3x. I'll do some work in there if I need to, and then I'll come up with an output of y. So I'm going to pick some numbers. I'll start with -2, -1, 0, 1, and 2, and see what I can fit on my graph. And so I plug in -2 in for x, and I find that, oh, I've got a negative exponent. That means I need to take the reciprocal to make it positive. So I see that I end up with 1/9 actually. So let me go ahead and fix that. So to make that positive, I have to take the reciprocal, and then I end up with 1/9. And so when I plug in -1, that just ends up making the reciprocal, which is 1/3. Plugging in 0 gives me 1, plugging in 1 gives me 3, and plugging in 2 gives me 9. So I've got plenty of points. Can't fit them all on there, but I'll do my best about getting some of them on there. So 1/9, and over 2 spaces to the left, up 1/9. Over 1 space to the left, up 1/3. And then over 0, up 1. Over 1, up 3 spaces. And that's all I can fit on there. And so what you'll notice is that the graph slowly gets close to the x-axis, but never touches the x-axis. So do not have your graph go below that x-axis for these problems, in this case here. And so that's what we end up seeing, is that it gets ever so close, but just never touches. So let's take a look at the next type of problem, and we have another graphing problem here. And so we're graphing this function, this exponential function. So I'm going to start with my chart. I've got some x values, and then I'm going to take the opposite of 1/3 of to the raised to the x power. So that minus sign on the outside is like -1 multiplied by 1/3 to the x power, and then I'll come up with outputs of 1, or of y. And so I'm going to try -2 to start with, and so when I do that, I have 1/3, but then I've got to bring it to the negative second power. So that's going to make, taking the reciprocal makes 9. And so 9 times by -1 makes -9. So I'm not going to fit that one on there, but I see where it's going. So negative 1 times by 1/3, all raised to the negative first power. So that's going to make 3, and 3 times negative 1 gives me negative 3. And then 0, well, negative 1 times by any number, doesn't matter what it is, to the 0 power is going to be 1, but times by negative 1 gives us negative 1. And I'll just go with one more number here. So I see that 1 would give me 1/3 of 1. 1/3 to the first power is 1/3 times by negative 1 gives me negative 1/3. So I kind of have an idea about what it looks like now. Over 2 spaces down 9. Can't fit it on there, but I know it's way down there. Over 1 space down 3. Over 0 down 1. Over 1 down just 1/3. And then this next one will be 1/9, so even closer. So you can see how they get really close to the x-axis, but just never quite touch it. So it comes up and gets close, but just doesn't touch it, and it goes down very quickly. So the next one talks about the population of deer in Grizzly Flats is 3,500. So this is an initial value. So this is your A term. It's your initial value. And then we see that in the year 2000, since the population has grown, okay, grown tells us that we are having a growth factor. So it's going to be a growth factor rather than a decay factor. And this is what it is. It's 0.3 or 0.035. So that's the number I'm going to end up using. So I changed that percent to a decimal. And if the trend continues, what will the population be in 2020? Okay, so we started in 2000. We're going to 2020. So let's write down what we've got so far. So we've got y equals a times b to the x power. A is right up here. A is 3,500. B is this value right here, but we're going to end up wanting to change this. Since it's a growth factor, we've got to add on 1 to this. And so I'm going to go ahead and add on 1 to make it 1.035, and that's going to be the b value. So that's going to represent b there. Now x is the number of years. So we're going from 2000 to 2020. So when you do that subtraction, you end up with 20. And so this is going to be our x value. So let's go ahead and plug in the numbers. So 3,500, your initial value, times by b, which is 1.035, all raised to the 20th power. So we go ahead and do this work right here, and I get a number of about 1.9898. So it's really close to 2. So I use that entire number. I don't erase that, and then I multiply it by 3,500. And so when I do that work, that gives me this number, 6,964.26. Well, you can't have 0.26 of a deer, so we're just going to go with 6,964 deer. Just somewhere right around that number is what we'll end up seeing. So the population New Haven was 148,220 in 2015, since the population has been decreasing. Okay, so we have a decay factor. And so we'll see what to do with that in just a minute. It's going down 2.9% annually. So if this rate continues, where will it be in 2025? So let's start with our numbers. We have A equaling 148,220. We have B equaling, here's where you have to do 1 minus 0.029. So you have to subtract the decimal form of the percent from 1 when we have a decay factor. And so that's going to end up giving us 0.971. And then we have to figure out x. Well, x is the time period. So we're going from 2025 to, or actually 2015 to 2025. So that's a total of 10 years. So we're going to use 10. So we go ahead and substitute those numbers in there. So we have 148,220 times by 0.971, all to the 10th power. And then we go ahead and multiply this out. And so I ended up with this. I ended up with a 0.74506, and then that number kept on going. I multiplied that by the initial population, and this is what I got. I got 110,433. And again, you get a decimal, 0.06 or so, but just leave that as a whole number, because you can't have a portion of a person. So that's what our answer is for number 6. Let's move on to the last set of problems, and it says that Linda invests $8,000 in a money market account that pays 3.25% interest compounded monthly. So now how much will the account be after 12 years? So remember, our formula goes this way. A equals the principal times by 1 plus the rate divided by the number of compounding periods, all to the nt power, the number of compounding periods times by the number of years. So our principal is the starting amount. That's the $8,000. Our R value is the rate, 3.25, but you got to change that to a decimal, so it's going to be 0.0325. And then our number of compounding periods, well, it's compounded monthly, so that's 12, and T is 12 years. So we go ahead and substitute the numbers into the formula. 8,000 times by 1 plus 0.0325, and then you got to divide that number by 12, because there's 12 months in a year, and 12 to the 12th power. And so we go ahead and do that work, and it looks like we're going to end up with, when I go ahead and do this work right in here, I end up getting this, 1.002708, and then 3 repeats. And this is all brought to the 144th power. And then I multiply it by 8,000. And so I bring this to that power. So I've got 8,000 still, multiplied by 1.47620. And then when I go ahead and multiply that out, I get $11,809. And then this is what I got here. It continues to go, but all I need is this. So I need the thousandths place to see how many cents I have. See, that thousandths place is going to round that to up to the nearest cent, to $11,809.62 is what that will end up being. So here we have a couple graphs. These are just linear equations. This represents the slope. And so the slope is -1 to 2. So it doesn't matter where the negative sign goes. It can either go on top or it can go on the bottom. And then this is our y-intercept. That's where the line starts. I'm going to start up 3 spaces and use the slope. So I can either go down 1 over 2 to the right, and I can do that a couple times, or I could go up 1, 2 to the left, and that's what this is telling me, up 1, 2 to the left. So up 1, 2 to the left, and that's what we get for points on the line. And the next one, again, this is our slope right here. And so the slope represents a fraction of this. If you don't see it a fraction, write it as a fraction, 2 over 1, which is the same as -2 over -1. So we'll use that in just a moment. Let's start with the y-intercept. So I'm going to start 1 space up and then use the slope. So it's up 2 over 1 to the right. Typically that's the way I go. Or I could go down 2, 1 to the left. And that gets me on that line as well. And then once I draw the points through the line, I've got my line. So those are the types of problems you're going to see on the test this week. Good luck.